Okay, picking up where we left off. The last thing I said was in the next video we are going to cancel those h's. And one thing I can't emphasize enough, that when you're using this definition of a derivative, your end algebraic goal each and every time is to cancel the h. These are, after all, limits. And I know I forgot to say it at the beginning, but if you did do substitution of h equals 0 at the very beginning of this limit, that would have given you 0 over 0, which is indeterminate, which tells you nothing. And when we were studying limits, the thing we always did when there was that 0 over 0 indeterminate form, we did algebra that would somehow allow us to divide out, cancel whatever it was causing the 0. So in these guys, what's causing the 0 is that h, and so your algebraic goal each and every time will be to cancel the h. So we'll do that. We will cancel the h, which then leaves us with the limit as h goes to 0 of negative 8 over 3 times 2 plus h. And now we're ready to evaluate the limit. We can substitute h equals 0 and finally get an answer of negative 8 over 3 times 0. 3 times the quantity, 2 times 0 plus 3, and that's hard to see. Sorry about it. Write it a little bit better. That's not a little bit better, that's a little bit worse. That's a little bit better. And so we get negative 8/9. And so remember what the instructions for this problem was, or were, way back when. It was find the slope of the function's graph at the given point, was the first instruction. The slope at a point is given by this formula, where I replace the x naught with whatever value they gave me. In this case, x naught equals 3. And so what we have found here is the slope at x equal 3 is negative 8/9. The derivative at a point gives you the slope. So there was the first set of directions. Find the slope of the function's graph at the given point. We did that. Now, the next instruction says then find an equation of the line tangent to the graph there. So we are going to have a little algebra view here. Algebra view. The equation of the line with slope m passing through the point x1, y1 is given by y minus y1 equals m times the quantity x minus x1. That's the point slope form of a line, which tells me to find an equation of a line. So to find the equation of a line, we need two things. One, a point. Two, a slope. Yeah, sorry, I need to move that up so you can actually see it. So to find the equation of a line, we need two things, a point and a slope. Let me go out just a little bit here. Okay, so we already know that the slope at x equals 3 of f of x equal to 4 over 2x minus 3 is m equals negative 8/9. That's what we calculated with the definition, the point definition of the derivative. We calculated the slope. So we still need to know, I'm going to try to write a little bit neater. I have horrible, horrible handwriting. We need to know the point at x equal 3. Well, I already have the x coordinate, so all I need is the corresponding y coordinate. So we need the corresponding y coordinate. Y coordinates always come from plugging into the original function. And so y is going to be f of 3, which is 4 over 2 times 3 minus 3, which would give us 4 thirds, if I did that correctly. Yep, that looks good. And so my point is 3 4/3. And so the equation of the tangent line would be y minus y1 equals m times x minus x1. Then plugging in what we know, that's going to be y minus 4/3 equals negative 8/9 times x minus 3. Now there is an equation of the tangent line, and if you're not told what form to have the answer in, that's an acceptable answer. And come test or quiz time, I will probably let you give me any correct form. But that's not a form we can easily check, and that probably is not the form that when you enter your answers into MyLab Math, they will accept, or the computer will accept. Generally, they want slope-intercept form, y equals mx plus b, so we're going to rewrite to y equals mx plus b, because that's probably what the computer will want, and that's a form that we will be able to check. So we're going to rewrite to slope-intercept form, y equals mx plus b. So first thing I'm going to do is clear those parentheses. And so I'm going to have y minus 4/3 equals negative 8/9 x plus, and then when I multiply the negative 8/9 times the negative 3, that's the plus, and then the 3 and the 9 are going to cancel, leaving me 8/3. Then add the 4/3 to both sides, and so I get y equals negative 8/9 x plus 12/3 for y equals negative 8/9 x plus 4. And there would be the equation of my tangent line. Now I said we can check this, and we can by looking at a picture. This was the equation of the line tangent to f of x equals 4 over 2x minus 3 at x equal 3. And so that means the picture needs to look like that. It needs to look like an equation of a tangent line. We need to see a curve with a tangent line. So I can check this on the calculator and get a rough feeling of whether I'm right or not. Now, disclaimer right off the beginning, the picture isn't going to look perfect, but the picture can give you a sense of whether you're probably right or probably wrong. So what I'm going to do here is, let's see if I can get it all on one thing here. Zoom in a little bit. And focus. There, I think we can probably see that. I'm going to graph my original function, and I'm going to graph my tangent line and see what things look like. So y equals, clear out the old stuff, and my function was 4 divided by the quantity 2x minus 3. So there's the original function. Be sure when you're doing fractions on your calculator that you put the entire denominator in parentheses, and if the numerator and denominator are at all complicated, entire numerator, entire denominator in parentheses. So there's my original function. And then my tangent line, I got y equals negative 8/9 x plus 4. So I've put the original function in there, I've put my tangent line in there, and then rough graph just to begin with, I'm going to hit zoom 6, the standard window, which isn't always going to work, but the way we write textbooks and things like that, things usually work on zoom 6. And even on zoom 6, I'm feeling pretty good about it. So I have the curve, which is that hyperbola. And then I have a tangent line coming right in here, and it's hitting just at one point. And so even on this setting, I feel pretty good. Now let's try to get a better picture. It was x equal 3. So let's redo the window, really kind of just zooming in on that x equal 3. And so if I go x equal 3, let's do a trace and just go to 3. You can see the blinking cursor there, so we're going to zero in on that part of the picture. So I'm going to hit my window again, and I think I'll go from -1 to, or maybe 6, a little bit further. And then on the y's, everything was mostly above the x-axis, so I'll go from -1 to 10 on the y's. And we'll graph that. And so you see the curve coming in, and it'll get darker as soon as I finish thinking about it. And then you see a tangent line. Now, because of the restrictions on the way the graph is, I can't come up with the words, it's never going to look like a perfect picture. It looks like it might be hitting more than one place. But if I do a trace, notice that point where it seems to be hitting, where x equals 3, right in the middle, so I feel good about this graph. And I think my problem's right, as opposed to something that would look wrong. So I'm going to change this. I'm going to just make one tiny little error. I'm going to make this -4, and then graph that. And there's my graph again. And this time, I don't see any tangent line. And go back to x equal 3 again. There's x equal 3. There's the point, and there's not a tangent line there. So that's clearly wrong, as opposed to what looked possibly right, which is this. There's the curve, and there's the tangent line, and it does look like I have a curve and a tangent line. So I feel good about this answer and think I'm right. Now, I have not proven that this is the correct answer, but I feel really good about it. And that's where we will end this video.